All right, so we're going to start talking about section 2.1 today, and this is angles and their measures. So the first thing I want us to talk about is what a ray is, and I know that you have seen these before, and even on your sheet you've got this sort of information that says half line in it, and a ray is actually a portion of a line starting at a point V and extending indefinitely in one direction. And the image is exactly what you think it should look like. So it looks like a line segment. It mentioned having a point at the end. So here's my point V over here. And it has an arrow at the other end indicating that it continues in that direction. Okay, so that's a ray. And we actually need rays far more than we need lines in trig, because rays are what make up angles. And angles are the primary focus of trig as we work with angles. So we need those rays. So an angle is actually two rays. You may not have thought about it like this before. With a common end point. Now they only have one end point, each of them, and they must share it for it to actually be an angle. And if you're taking a look at what that image looks like, whoops, hang on. We have this going on, two rays, and they share this endpoint V. Along with this picture, let me actually continue on this in this image with what you're going to see next, is you have an initial side and a terminal side, and we'll determine which ones they are later based on the description, but one of them is one and one of them is the other. It doesn't have to be that the one that I'm writing here as initial side is the only way to do it. So initial doesn't have to be the lower one or anything like that, but there is an initial side and there is a terminal side. It's running into my words. So an initial side is simply one side of the angle, or one ray of the angle. And a terminal side is the other ray. Let me just comment too that it seems like we're doing just a lot of writing right now. That's not how it's normally going to be in trig, okay? And we're just presenting a lot of the information you need at the get-go. A couple other things, and many of these are things you've seen before, like in a geometry class probably, or if you've taken trig before, you've certainly seen them before there as well. The vertex is the point V shared by the two rays. There's two different types of angles, or an angle can be described in two different ways. You can describe it as a positive angle or as a negative angle, and it has to do with the direction of rotation. So a positive angle is a counterclockwise rotation. I'll draw a picture. And then the negative angle is a clockwise rotation. So if you're taking a look at these angles that I drew before, counterclockwise looks like this. So if it's an angle where the initial side is that lower one and the terminal side is the upper one, that is a positive angle. And then a negative angle would do exactly the opposite. So I'm going to use the same picture, and it would go like this. So instead of it opening, if you will, clockwise, counterclockwise, it opens clockwise. So in this picture with the yellow arrow, the initial side would actually be the top of the angle, and then your terminal side would be the lower part of that angle. All right? All right, so degree measure is crucial to what we're going to be talking about. And you know degrees. It's probably the first thing you learn when you learn about angles in elementary school is you start talking about how many degrees things have. And you usually start talking about them in reference to other shapes, like circles and triangles and squares and rectangles and things like that, right? Talk about right angles and things within images. And so degree measure is the first one. And degree measure, 1 degree, whoops. And of course the notation is a little degree marker like that. 1 degree is 1/360th of a revolution around a circle. And we will typically use Greek letters for angles. Okay, not always, but typically we will. And so you'll see things like, in particular, the most popular one probably is theta. But you might also see an alpha or a beta or a gamma or something like that. So you're seeing Greek letters used in that context. There are there's really 5 types of angles. We're going to talk about 4 types of them because they are the most universally described. So tell me, what is an acute angle? Okay, so specifically not just less than 90, but it's between 0 and 90, right? Remember, we talked just a little bit ago that we can have negative angles, so we're not talking about negative. We're only talking about positive in this context, so we'll be real clear. So this is 0 is less than theta. We'll use that for our angle, is less than 90. So it's between 0 and 90 degrees for our angle. So how about a right angle? What is that?
90 degrees.
Yeah, that one's exactly 90 degrees. What's an obtuse angle? What is it? Between 90 and 180. Very good description. So sometimes people want to just say it's bigger than 90, but it really doesn't just get to be bigger than 90. You actually have it a little bit trapped as well, like the acute one. It's between 90 and 180. Because what is a straight angle? 180. It's also otherwise known as a what? A line. Yes, it is. Now, I would be remiss if I failed to at least tell you what the missing one is. The missing angle is called a reflex angle, and a reflex angle is actually considered to be an angle that's between 180 and 360. But if we simply measured in a different direction, it automatically becomes between 0 and 180. So that's kind of a confusing way to think about things, but that is another one that you sometimes see in books. Okay, this will be our last slide. Standard position. So an angle theta is in standard position if its initial side is on the positive x-axis, with vertex at 0, 0, or you can say at vertex at the origin. Now I want to draw a picture of this, and then we'll talk about what quadrantal means. So if you have a axis, it's not perfectly straight, but we have this kind of an issue. We've got an angle starting here, right? Initial side with the vertex right here at the origin. And then the other part of the angle, the terminal side, can be anywhere else you'd like. So maybe it's over here. Maybe it's not, but this is one option. A few things to be aware of, and again, you've seen these before, is that these are called quadrants. This is quadrant 1, 2, 3, and 4. And your angle measures here are related to the different angles that we talked about. So this has an angle measure between 0 and 90 with degree markers on them. This is between 90 and 180. What's the next one? What's in quadrant 3? It is, that's true. It starts at 180. Where will it end in this particular quadrant? Yeah, no, you're fine. 270, yeah. So this one will end in 270, and if you were actually in here, it would be a reflex angle. And then the last one is actually from 270 to where? To 360. That doesn't much look like a 3, but pretend for me. Quadrantal angles, I know I don't have much space and much time, but let me just tell you what a quadrantal angle is. A quadrantal angle is an angle that's actually between quadrants. It's an angle that's 90, 180, 270, 360, and we're going to say etc. because we're going to see some more later, but in particular, its terminal side is on one of the other axes, and that's a quadrantal angle. We'll stop there for today.
You said it's consumed,